Thank you, Aud. Now it's my pleasure to introduce you, to welcome you here. I would like to introduce Audrey Samson and Simon Roloff. Audrey is mainly an artist, or better we could say a researching artist. She's currently a Stanley Picker Fellow at the Stanley Picker Gallery in London, and one of the two members of an artist duo called Fraud, which is a very nice name for it. And besides, Audrey is also a professor of modern computational arts, also a really nice name, at l'École de Recherche Graphique in Belgium. And when I looked at her really huge oeuvre of pieces of art and the many websites and projects you've made over the past years and you were working on, I found it really fascinating that you're doing your research on the intersection of technology and data and critical ecologies, like, for example, questions of how does data materialize in the world, like in a kind of a feedback loop, in a cybernetic kind of feedback loop where we could say that data is observing the world and then it does something in the world in the second part, and I find it really interesting. Maybe we can talk about this later. And yeah, today Audrey is talking about this topic, intelligence and interpretation.
I added the last part.
You put another title, brain or hallucination to it.
I
also
want to
very
keep
good.
you on your toes.
That's very good, yeah. Thank you. And of course we have Simon as well. And Simon studied cultural science, philosophy, German studies and literary writing at the Humboldt University in Berlin and at the German Literature Institute in Leipzig. And he made his PhD, his Dr. Phil at the Bauhaus University Weimar. And then it followed the junior professor at the Hildesheim Literature Institute. And I think currently you are a senior researcher at the Lausanne, at the ICAM or ICAM Institute.
Exactly.
What does it stand for, the ICAM?
I never know. Something media.
With media, that's very good.
Yeah.
And I also find it very interesting to look up your work and what you've done in the past, and because I think you're one of the researchers who very quickly saw the potential of AI-assisted writing and literature, and also in the last few months you had several talks about this topic. For example, a talk with Sibylle Krämer on chatbots, and on literature as artificial communication with the sociologist Elena Esposito. And I think today you're talking about AI noir literature and experiments with large language models, of course, and I find it very interesting to talk about later. So we prepared this session that first Audrey is you're holding your talk, then Simon, and after that we can go into a discussion with you, of course, the audience, and I prepared some questions as well, and then we have a chat on the sofa. Yeah, so let's start with Audrey. Thank you.
The lights, just a little bit. I'm thinking that it seems quite okay, no?
It's fine. Yeah, it's fine.
It's not so. It's not like this morning because it's darker. Also, well, just to start, thank you for the invitation, of course, and for curating this lovely group of people. It's been quite a nice day so far. So what I would like to propose is to think about how we think about knowledge production that's generated by automation, but I'm specifically thinking about the non-human. So we spent quite some time today thinking about the capture of humans, but I'm thinking more about non-human capture, specifically about the environment. And I want to think about how that has changed from interpretation to intelligence. And for this thinking exercise, I'll be mainly looking at a historical example, kind of media archaeology really, which is photogrammetry in the context of its development in industrial agriculture. It will be quite precise and somewhat geeky in its level of detail, I warn you. But I'm also interested in looking through the usually female-identified interpreters that were central to image analysis. So just to give a little bit of context, I'm an artist, so the research that I'm showing is stemming from installations or performances and kind of in discussion with them. So it's a kind of an artificial separation that I'm making, and that is perhaps a little odd and that I'm trying today, so we'll see how that works. And to give a little, although you gave such a great introduction, but I just wanted to add that in the fraud pack we're looking a lot at contemporary forms of rationality, thinking about, that are embedded in computation, such as risk analysis or carbon accounting or impact assessment, or what Foucault would call analytics of domination. So this is something that we've been sort of looking into, so you can understand a little bit the frame of the things that I will show. But first I wanted to gesture to the banality in the title that I added yesterday. So this is a quote from anthropologist Elizabeth Dodd, and she argues, somewhat provocatively I think, that what survives in public records are bureaucratic reports and balance sheets, calculations about what is extracted at what cost. History, as we know it, is a series of environmental assessments. For me, this quote speaks to quite some relevant points, but I'd just like to understand, not to understand, but to emphasize how here the making of history is really a collection of really quite banal bureaucratic reports. So the more or less really boring stuff that no one pays attention to is quite sort of critical in the making of that history. And perhaps now that AI is everywhere, and I also use this word like Paul this morning with some reservation, but perhaps now that it's everywhere I might become interested in it again, because I had quite some years of disinterest of late. But because of its banality and its pervasiveness, I think then it becomes quite crucial to pay attention to, and that's why I have perhaps a renewed interest of late. So I mentioned that this has been sort of research that comes out of performances and installations, and they were concerned with the agency of predictive systems to perform the future, or also the operationality of technical assemblages, which is something that we've talked a lot about today. So what I will show is an interpretive account of the representational abstraction that reorganizes land, like materially, really, and the species inhabiting it, and thinking about or considering how knowledge is really organized through those lenses or produced through those lenses. So I start with an anecdote, towards the politicized nature of labor mechanization, and I hope that it serves a bit to contextualize the discourse around efficiency that really shrouds the history of technological development, which we've also talked about today. And I want to discuss how the aesthetics produced by industrial agriculture really become machine-readable and compatible with the cybernetic conception of systems. So the great Lewis Mumford once wrote that the new colonists, this is of course North America, lacked labor power, and they were therefore propelled to invent labor abstracting devices in agriculture, namely. And I think that Mumford was quite short-sighted in this specific point. He really overlooked the messiness of human laborers, their ability to organize in demand of basic requirements, like, maternity leave or a decent pay. And this, of course, is a motivational factor to develop mechanical replacements throughout history. It's not the only one, but it's certainly a topic that recurs. So I think that the politicized nature of labor mechanization is really exemplified in the marriage of this agricultural engineering between plant breeding and engineering, which occurred between the VF-154 tomato It's also called the square tomato, and the UC Blackwelder mechanical tomato harvester. So they're both engineering marvels, culinary tragedy, and a testimony to the kind of long overlooked anti-unionist and xenophobic incentive to develop machinery and also remote controlled equipment for harvest. So two scientists at UC Davis, they teamed up, this is about in the 50s, to invent a machine that could mechanically harvest tomatoes, which seems quite banal to us now, but at the time it was quite groundbreaking. And the devices were optimized for monoculture production, of course, but most importantly, it's that the tomato, the plant species, was optimized to fit the machine and not the other way around. So the development of the machine, along with the development of the tomato, especially the tomato, was sort of engineered to withstand the bulk or the rough touch of this harvesting machine, which, oh, now you don't see it so well, but you can imagine that it's surprising that the tomato is not being smooshed to bits actually here. It was actually reported often that one of the scientists, Gordy Hanna, apparently went to highways to throw the tomatoes off the highways to test their impact resistance. But maybe more crucially now in this story is that like 1962-ish, the machine and the plant, they're market ready. And 2 years later, sorry, not accidentally or anecdotally happening at the same time. What's the word for that in English? It's not coincidental.
Simultaneous.
That the US government at this point refuses to extend the provision of something called the Public Law 78, which was basically allowing foreign nationals to come into the US to help with crop production and harvesting. Right, okay, it's playing. So this phenomenon is cleverly alluded to, I think, in this mock marketing video from Alex Rivera. It's called Why Cyberbraceros, so it's like Why Cyber Arms in a way, a translation. And it's basically sort of talking about or making a mockery of the ultimate American dream. In this case is one where immigrants can labor in the US but remotely. So they never have to live in or become the responsibility of the American society, in short, the perfect immigrant. And I like to show this video also because I think it becomes even more relevant with AI being posited also, of course, as trouble-free, efficient, low-cost laborers. No? These tropes come back. And just to mention that a few decades later now, fruit and produce sector in the US is a system that uses migrant labor. 70% is migrant labor, so it's really high. Sorry, I should say undocumented migrant labor, 70%, and also increasingly carceral labor. So this is sort of where this goes. But to move back to agricultural data analysis, I think also we can see, or I like to imagine that the mechanization of labor also ushered by monoculture and these engineering developments was also unintentionally catering to the eye in the sky. No? They inspire a mathematical readability of space through calculable parameters. And these parameters or categories also then become the founding categories of photogrammetry that are still used today, which I'd like to kind of spend some time delving into. And I have no idea how long I've been speaking, so please tell me when it's a bit too long, because I have a propensity to speak for a really long time. So I'm showing this slide just to show how, in a way, these neatly isolated variables can really inform narratives of economic growth, right? And facilitate the application of this circular causality, or the regulatory logics of cybernetics, right, that we can see quite easily here. And the prairie townships, which is an area in Canada that is very flat, that I will show in a second, becomes a kind of surface that's easier or easy to capture, to measure, and to evaluate. These are the kind of fields that I was thinking about. And the input and output paradigms, which is, of course, some kind of basic understanding of the cybernetic systems, and also financial operations, they can now really be easily measured in land allocations, such as, and now I'm reading from actual land allocations, you could have input, petroleum, fuel oil, raw sugar, motor vehicles, and the output, grain, newsprint, flour, lumber. So the tools mechanical harvesting produced ushered in an aesthetics of machine readability, but also, I think, facilitated narratives of this circular causality. So the aesthetics also facilitated crop analysis using photogrammetry that was based on views from above, of course. And now I'm showing very early instances of photogrammetry. Contemporaneous modes, of course, of capture, measure, and valuation, along with the forecasting based on machine learning, are also rooted in still these traditions of methods that were earlier developed for interpreting aerial photography. So for me, it's quite relevant here to maybe emphasize that before these photographs were processed by trained algorithms, pattern recognition and analysis was termed photographic interpretation. So geospatial intelligence comes much later. So in 1960, the preface of the American Society of Photogrammetry and Remote Sensing produced a volume called Photographic Interpretation, and it describes the practice as follows, and this is a quote from the introduction. The practice is akin to detectives who are involved in the extraction of valuable information from aerial photographs, obscured by nature's camouflage. End quote. So these massive fields that were dedicated to manual culture were one of the areas where such extraction was, of course, pioneered. So photogrammetry was largely used to survey geological structures, draining patterns, also agricultural areas, of course, and they could indicate things like lithology or soil structure, as well as crop yield forecasting, which was probably became the most important part of it. And they used various types of films. We may remember photography when there was film, actual film. And they were these films were employed, or different types of films were employed to capture oblique and vertical views. So they were created with only 2 images from a different angle. And they were used to detect crop properties depending on the wavelengths that they absorb and reflect. And this is also still very much used today. I give an example in a diseased leaf sometimes, and it's a bit technical, but the spongy mesophyll tissue, which I'm surely mispronouncing, but it's usually highly reflective of infrared light. And so when there's an issue with the plant, it collapses, but for a while it remains green, so it's not visible to the human eye, but it's visible to infrared light. So this is one of the ways that they use to predict crop yield, to detect if that disease is there. And again, these techniques are still used today, obviously not with pellicule film, but... And so much like today also, but with fewer images, but nonetheless the images were aggregated and compared for analysis, though it was accomplished at that point with this beautiful object, sometimes vertical stereograms, and this was to understand topography. Stereograms were created by using 2 images of an area taken from the same height but at a different angle, if you can imagine. And they were collated with the help of a mirror or a scanning stereoscope with a binocular attachment. And this was used to plot boundaries or terrain features or the area, on the aerial photographs. And this analysis of the images was, of course, used to determine pattern detection, and also a combination of geologic, also drainage, and crop pattern features. And so these methods that were developed during wartime, this was developed during wartime for detecting the enemy's military positioning from above. But this was then quickly applied after the war to a field that became the rural economy. It became known as rural economy, and I'm just saying this because I want to note the explicit link to financialization already. And so in, again, the American Society of Photogrammetry's book, which is quite large, the visible characteristics of this rural economy were defined as such. So land use, density of settlement, farm buildings, farm lanes. And the land use is categorized in only 4: fields, improved meadows, unimproved meadows, and pasture. So I think the categories also give us an indication of what kind of value we're prioritizing. So crop patterns in aerial photography were largely developed, or not developed, but determined and understood through tone and texture. And I think that by looking at this, for me, I can already think about the algorithm's pseudocodes. You can imagine something like if tone is nearly white and texture is speckled, type of land use is field. Or if land use is field and tone is light gray, field is small grain. Else land use is unimproved meadows, no? So in the 60s, while automation was being researched, the analysis that was central to photogrammetry was being accomplished by what was called an interpreter, and also sometimes a computer. It was invariably a human at this point, and usually female identified. And it was also understood that the properties of the interpreter that they were trained to detect, like this texture, pattern, and tone, it was understood that these were qualitative properties and that they were appraised subjectively. This was explicit. And the complexity of this appraisal also lied in actually the knowledge that was required to kind of put into relation the multifarious interrelations between soil, plants, and weathering processes, and also in recognizing their combined agency. So that's how the American Society of Photogrammetry defined like what the interpreter did and their kind of expertise. And if you would go so far as to read their training manual, which I did, you would find different sort of training questions that they use to train the humans to interpret, such as, is the pattern location related to A, land, B, water, C, continent, D, subcontinent? And it kind of goes on like this in, again, you can almost see the algorithm pseudocode being written through this training set, which is all with choix de réponse, how do you say? When multiple choice, yeah, thanks. But still the conclusion was ultimately that it was a subjective process, that it was achieved through the interpreter's deduction, right? And I think it's interesting to me to notice how the task that was, interpreting, that is now largely being delegated to computer assemblages, has become considered a form of intelligence. And so the methods and the conclusions that were inferred by the female-identified human, which were deemed subjective interpretation, they become understood as objective when they're performed by the machinic. No? So I also wanted to just mention briefly that wartime photography analysis that developed during photo interpretation also became integrated into the economics of farm production. And so, perhaps unsurprisingly, software based on pattern recognition that's used to predict crop yield contemporaneously is an area of significant interest to different military organizations. Oh, I better really move. Okay. So I wanted to talk about how this has become a military interest. It was initially, and it's come back again, and that one of the major interests has been through the American DARPA, basically, and that one of the reasons why they're interested in this is because they can use crop yield prediction to predict social unrest that is linked to inflation that's caused by the rise of agricultural commodity prices, one of the alleged key stressors of the Arab Spring, right? So agflation may cause uprising, and therefore DARPA is very interested in this. So I will skip this to go a little bit quicker. One of the companies that received a lot of funding from DARPA is the New Mexico-based Descartes Lab, and I just wanted to talk about it briefly because this is that we used actually their data, and I'll try to keep it as quick as possible. But the Descartes Lab was founded about 10 years ago, but it was a spin-off of the Los Alamos National Laboratory, so host of the Manhattan Project, the World War II nuclear bomb project, but also a former private ranch for schoolboys. And so in addition to their business solutions, they also offer a platform that's accessible through a Python client, and you have access to a very limited amount of imagery, more to kind of give you an idea of how it could work. But I think who is granted full access of the data and at what cost becomes like quite, I think, pertinent in considering the power dynamics in geospatial intelligence services, which are usually like very large scale, extremely expensive, totally not accessible for people such as ourselves. So Descartes Lab, now many years later, or in 2022 anyway, they describe themselves as global scale predictive intelligence. And I think this really presents a clear ontological shift, right, from interpretation audited by the female identified computers to the machinic intelligence. And I'd like to very quickly draw your attention to the discourse of efficiency, because I think we also mentioned this today, that's put forward also by geospatial intelligence companies such as Descartes Lab. We create new sources of operational advantage for our customers and partners by combining multimodal data with machine intelligence to deliver solutions quicker, more efficiently at a planetary scale. According to Descartes Lab, their services also enable a better understanding of the physical world through scalable analysis of geospatial data. I feel it's quite reminiscent to the description from the American Society of Photogrammetry some decades earlier. But efficiency has sort of made its way into the definition. I wanted to mention that Hannah Arendt has warned us of the seductive potential of abstracted tools of analysis already like in 1958 in The Human Condition, and that she explains that the disembodiment of I and body, or I and mind, really creates a distance that is powerful, of course, because it's inherently reductionist capacity. So I think this begs the question of what kind of ontoepistemologies are being mobilized by geospatial analytics, or perhaps, as Paul mentioned, how they're being instrumentalized for capitalist gains. I think that's a very important question. How much time? No time? Okay. Well, I will finish with the slides then. That space, I think the idea of conceiving space as having preemptive potential is very alluring, similarly alluring to the discourses around continued growth that are made possible by ever more efficient systems, and it's also big business, as this fraud tone would suggest. But I think it's important for me to foreground how it's based in an ontological ordering of the world, namely this Cartesian reduction and translation to the world of the world in algebraic formula. So as I've gone way over time, I think I will simply finish maybe by saying also to position myself with what's been said today, which has been like really a great prelude or setting the stage in such a fantastic way. I was not really thinking about making an evaluation of machinic analysis per se, but rather thinking about the human instrumentalization of it as some kind of objectivity, which I think should be criticized. And last thing, I was also thinking about the move from interpretation to intelligence. Interpretation is a verb, and I think that a verb rather than a noun is more interesting to think about, like the co-creation of it, this kind of iterative process that we've talking about, and also the fact that, well, it emphasizes the co-construction, and I wrote something else, and it emphasizes the apparatus's meaning-making. Those were my notes from today. Merci.
Okay, yeah. Yeah, thanks, Audrey, and thanks for everybody for inviting me and putting together this beautiful workshop, the workshops and the conference. And I'm quite happy to be talking about this because, yeah, as Samson said, AI has been sort of what I've been doing in the last half year, and I'm always glad to talk to other people what they're doing with it. And I can draw upon something Paul said in the morning, also some things Audrey said just before me regarding intelligence. And I'd rather start with a simple observation that we began calling machine learning artificial intelligence precisely when these kind of systems developed the ability to process language in a way that allowed us to think of them as human counterparts. And this connection between intelligence and language, of course, is so ingrained in our cultural imagination that even the Turing test Paul was talking about this morning is part of it. If you recall what it was about, actually, this famous idea Turing put about in the 1950s, it was less about intelligence, actually, than in a general sense, and more about linguistic performance. Because the scene Turing dreamt up back then, it was pure speculation at the time, is that a human judge interacts via written text with two unseen interlocutors, one human, one machine. And if the judge can't decide which one is which, then the machine has passed the test. So that's the basic setup Turing was talking about. And this does not assess machines as being intelligent in any capacity, but instead it measures the machine's ability to perform human use of language for purposes of communicating with other humans. And that is quite a distinction, and usually people know it, but it's important to start with it, I think, when we speak about intelligent machines. And you know, already in the 60s, Joseph Weizenbaum's ELIZA was able to fool people into thinking that it was intelligent and passed the Turing test, and achieved this by imitating like this specific therapeutic conversation style, reflecting the user's input back to himself or herself as questions that make them feel seen, or reframing their statements to keep the conversation going. And many users just felt really seen and part of an attentive and understanding conversation. And not because the program had any understanding, of course, of their statements, but because it just successfully mirrored human use of language in a specific, narrowed setup of conversational style. So, and it's findings like these that led the sociologist Elena Esposito, who I talked to last week in another conversation, to argue that it's much the same in contemporary LLMs, that it's more accurate to say than they are artificially intelligent is to say that they imitate our modes of communication. in building on this idea, we could say that they do so by hacking or imitating our media of communication, like the basic cultural techniques of human thinking, numbers and written characters, which of course are more pertaining to what I'm going to talk about in the next few minutes. So, and literature has this tendency to reflect its own technological underbelly for the last centuries, and can do so again, I think. And I shall try to make this, to show you this with showing 3 examples that I really like contemporary examples of experimenting with language in a literary setup. And by viewing artificial neural networks through a literary lens, we not only uncover the technical mechanisms underlying their operation, but we can also learn to understand them better. And I think crucially, this involves perceiving our artificial communicators, communication partners as less intelligent and less autonomous than we're expected to see them. And so basically it's all about seeing them as mere tools with certain technical strengths and weaknesses, and sort of take out the air out of the whole advertisement talk about artificial intelligence. So I'd like to begin with one example, really simple setup, which I really like, which is quite beautiful, actually quite early, 2019. So a lot of things have happened since then, and it's not with a large language model, but with an RNN. And it's a work by the author and programmer Alison Parrish that uses an artificial neural network to explore language representation as a fundamental principle in machine learning, something that is basically the basis for everything we do right now with ChatGPT and such. So in the piece Compasses, Parrish worked with a recurrent neural network designed to handle both phonetic and phonetic written representations of language. The network combines 2 functions, a pronunciation feature, which translates input words into vectors, and into mathematical vectors, which is just a series of numbers encoding the phonetic properties of the word. And the other one is the reverse function, which is a spelling function, which reverses this process by reconstructing written words from the generated vector. And vector spaces, of course, are a cornerstone of language representation in machine learning today. It's what makes architectures like GPT or BERT work at all. And in the case of GPT, they map semantic relationships between words and vector spaces to infer meaning. In the RNN employed by Parrish, it's a similar technique, but it's applied to represent the phonetic qualities of words. For instance, the words bank and bake will be closer in the vector space than bank and balk. And Parrish uses this feature, this spatial representation, this mathematical representation of words that can be spatially interpreted, to generate vectors for 4 word inputs, for example, north, east, south, and west, in the example I put out here. And when the vectors are calculated by the pronunciation function, they, Parrish, intervene to transform the technical apparatus into a poetic experiment. It's not she, she's they, she's non-binary. They calculate the mean values of the vectors, blending the phonetic and spatial qualities of the inputs. And these calculated vectors, these calculated values are then fed back into the RNN, and into the RNN spelling function, which decodes them into entirely new non-existent words and prints them out. So thus creating neologisms that serve as a phonological hybrid of the prompts the network was given at the beginning. So earth, woust, all these kind of things. So it's a new machine language, if you will, and it's quite simple as a setup, but so effective. And of course, she can produce any number of poems with that, and she always arranges them alongside the original input in the shape of a compass rose, and creating this poem of like a concrete poem of transitional word forms. And the spatial representation encoded in the model's hidden layer is projected onto the page of the poem, and it forms a concrete poem that uses technical proficiency for literary effect. And Compasses is, I think, is a good example of media reflexive poetry, something that is able to map the technical process that actually is at work in machine learning into a literary form. Moving on to my second example, and I'm so sorry, literature is always at this disadvantage that I can never show you anything. I don't have any pictures. I had to think of, should have thought about that, but it's just, written characters. And you will have to go with me through that. Hannes Bajor's Berlin-Mai is a German example of AI literature, quite recent. It came out last year. This is a literary experiment that interrogates how large language models handle narrativity, and under the conditions of statistical text generation, of course. Rather than training a large language model from scratch, Bajor uses fine-tuning, which is a process where you actually put your own data set on top of the data set that already created the large language model to make it perform in a slightly different way. The advantage is you don't have to give the machine examples how language works. It can already use grammar. It can do a lot of things. It doesn't have to relearn everything by itself, but you can push it towards a certain quality of generative content that you want to achieve. For example, a certain stylistic tone you want to have in your text, which you can really achieve. I don't know if you ever tried ChatGPT to write in a really certain way you want to write it, or in a certain style that is not in the data set. It doesn't work. So that's something you can do by fine-tuning, and it's quite an effective technique when you do when you do serious literary work with LLMs. And so Hannes used for German-speaking novels Pixel Tensor, Flexen in Miami by Joshua Gross, Miami Punk, which is by Juan Guse, and Realitätsgewitter by Julia Zange. And these novels share sort of a thematic focus on digitality, and which is sort of the conceptual way of putting them together, and the reason why you put them together, and then it's important how he prompted the network. He did not, just how you maybe would like to try it is, he didn't just say the network, please write me a novel, but he used text completion, which is sort of the traditional way of working with GPT architectures. He started with typing a single letter, word or a punctuation like E or a quotation mark, and prompted the model to complete the input probabilistically and create the next sentence of the novel. So sentence by sentence, very slow, very deliberate setup of working with this kind of thing. And this iterative process reflects the generative mechanics of LLMs in general, I think, which excel at predicting the most statistically likely continuation of a sequence based on the training data, of course. And at the same time, this minimalist input strategy shifts creative agency in a way to the model, with each step producing what Bajor describes as surface narrativity, a text that, but in my mimics the flow of narrative while exposing the fact that LLMs do not actually have a concept of narrative or of sequentiality, of continuation like we do, because they don't hover in the same physical space that we do, and they're not analog. So that's what Bajor is getting at with this concept, with his experiment. He wants to show again, because it's kind of hidden now from us. When we use chatbots, they have such great qualities of producing a continuous flow of even of narratives and such, and he wants to basically walk it back a few steps and say, okay, but this is still a statistical narration, still a statistical approach to what we are regarding as a continuation or a flow of things, and that's basically what he's getting at. And he was, I think, he was inspired by Angus Fletcher's thesis on narrativity. He says that large language models can never produce real narratives, because that affords some sort of quality of being able to think in a sequence like therefore, and not and. Like you need to have causality, not just continuation and correlation to make a narrative. And yeah, so that's what we were getting at, and this actually it shows quite well in what in the text he generates with his model, because it does not produce a really good narrative. It's just very inconsequential, very absurdist even, and just the sequence. I have only recently moved into Ramona's conversation module. It is located 2 streets away from my apartment block. I met Ramona in the Miami skyline and asked her to lose the football allegiance. More speakers than necessary have been built into the loudspeakers on the door. Leaves to play the song that is announced during the concert tuning for the apartment block. So this is kind of like an exemplary phrase that Bayur generated with his model, and it's really bad, of course, and that is the intent, right? So with this kind of setup, you can show how a large language model actually works under the hood if you take away some sort of its capabilities that it has gained now in the technical development of the last 3 or 4 years. And so my last example is my own work, something I'm working on right now, which is a project where I provided an LLM with data entries from the US National Missing and Identified Person System, short NAMUS, which is a database containing about 23,000 entries from people that disappeared in the United States, starting from 1900 or so. And each entry includes factual details like date of birth, place, date of disappearance, physical descriptions, and sometimes circumstantial notes on the disappearance in this concise protocolary style of police reports, which I found it quite good that you started with bureaucratic ideas of data gaining, because I think that's quite an important point when we talk about AI as well. So, and to address ethical concerns in working with this data, I anonymized them using a small Python script that created randomized composites from the original information. So it's ensured that no real person's identity could be traced back to the narratives I generated. And then I prompted an LLM with these anonymized entries, and it was like in Hannes setup with Berlin Miami. It was a text completion model that I fine-tuned with literary text from Elfriede Jelinek, Thomas Meinecke, and Niklas Mark. And these texts are referenced in an article about biographical literature and digital culture, so I just took them, so I didn't have too much agency in creating the data set. I thought that was important at the time. And the prompts then initiated a text generation process, sentence by sentence again, with the generated result each time fed back by myself into the new prompt to force the model to regard the previous generation as its context. And this then generates a text that leaves the NAMUS prompts unaltered in the first paragraph, and after that the model builds upon the input, crafting a narrative that veers into the speculative and about, in fiction, sort of. To give you an example, this is a prompt I made from the NAMUS data. Dark brown eyes, white straight hair, grey tennis shoes. It seems that a soldier who later stated that he had been asked for directions by him had misunderstood him, and so the missing person was directed to Nolensville instead of Lobelville, which is in the opposite direction. The car was found with the keys still in the ignition, the battery dead, the driver's window rolled down, the back door open. There was a box of matches on the dashboard, although the missing person had not smoked in years. Piles of branches and bushes surrounded the vehicle as if someone had wanted to start a fire. So this is data I took from the database, which have been actually recorded in police work. And then I prompted the network with it, and it came up with a story about a detective who suspects something and goes about his work, tries to find the missing person, but does so by going fishing and dreaming up a scenario where he travels in between each city in the US, which are connected by assonance, sort of, Tucson and Tucson, and so on and so on and so on. There's quite a lot of things, and the model or lists them in the way which all the cities that have sound the same. And it's quite a nice story actually. And then of course, it's a failure, and he cannot find the missing person like that, and then he writes to the wife of the disappeared that he will finance the creation of a machine that is all-knowing, and that where everything about the disappearing person will be known, like his car keys, where he locked up his car keys, his hobbies, wherever everything. So it's kind of like a self-reflective move by the model at this point. So, and obviously, I think my main point about this is that this occupies an ambiguous space between fiction and documentation. Sort of the texts generated start with some sort of real-life data that become a speculative narrative that could never have been thought of by myself or of course not by anybody living. And I think, kind of what was important to me when I started the project was this, also of course this concept of the data doubles that Paul was talking about in the morning, but also Colin Kopman's concept of the informational subject, of the data cyborg, if you will. The fact that we are all living our lives as a physical entity, but also gradually, growingly inside of a data space where we're just statistical information. And I think these kind of narratives, they show the perspective in a way that NNI has on us. You know, it's this, we're nothing but some sort of correlative data that can be used to infer meaning from it and infer a narrative from it. So that's basically what you can take from small field data and the way it starts to tell stories. In summary, I'm gonna finish up now. I think all these examples show like they have a literary dimension, of course, foregrounding language as a medium of artificial communication, and at the same time they shed light on one specific detail of artificial communication, and also the cultural conditions that shape the way this communication unfolds. Paris Compasses explores the representation of language in a vector space. Bayor investigates narrativity and the conditions of statistical generation, and Small Field Data, in its own small way, examines how large language models generate docu-fictional data cyborgs from real-life individuals. Yeah, maybe this can lead in the end to some sort of broader reflection on what unites literary experiments right now. At this very moment, they present language generating machine learning is deeply tied to the principles of its underlying technology, whether through the vector space representation or through the weights of RNNs and LLMs. And one effect of this is that we encounter a machine-readable, a machine ensemble that is less autonomous, but rather bound by fixed algorithmic, logical, and statistical patterns. And literature then, in the end, helps us understand AI better in a very specific way, I think, because we have this huge problem with machine learning systems that they tend to, for example, overinterpret their tasks very literally, like overly literally. Like this, it's a huge discussion in AI alignment. For example, if you task a system to win a race by hitting certain checkpoints at a racetrack, it might do so but it usually will cut corners. It won't adhere to the racetrack, but just just go in a straight line from checkpoint A to checkpoint B. I'm finished in a second, don't worry. and it just, it's called misalignment, basically. We will not have AI systems do tend to be overly servile to what we want them to do. And another example, of course, is something that came up in experiments by the US Navy. They had simulations with an unmanned aerial drone that had a mission and tried to kill its handlers when they tried to make it aboard the mission. So it just had to, of course, it had to fulfill the mission. That was the first priority. So, and not to make that happen is, of course, something that AI research is about right now. But I think it's important to understand and to remind ourselves that AI will maybe never be fully aligned with what we are. Never be fully aligned with the contextual objectives that we tend to move to, the ways we try to make something happen that are very much different from its algorithmic qualities. And these kind of literary examples then show in the end, I think, how AI works and make us understand AI much better when it's not as intelligent and not as autonomous as we are led to be thought about it by people who are really interested in making us do so. Thanks very much.
Thank you so much, for both of you. Thank you so much. Very inspiring. And I was thinking about something that combines all three lectures I heard today. Like the first one this morning by about the intelligence of 5,000 years ago, and now you both. And I was thinking about the word from the first keynote. He mentioned, mentioned the latent space, and I think it could be a metaphor or a synonym for something that you both are interested in, like the vectorization of the language world or language relationships, and in your lecture the thing of observing and formalizing in a kind of way the world by data, like with these tomatoes or the crops and stuff like this. And yeah, I don't know what my really my question is at this point, but I think there is maybe the latent space metaphor could be something we are experimenting with by using these AI methods right now. And another one could be, or would be my question, if it really makes it different if we're using this technology, or if we as human beings are doing the same, if we as human beings also only in abbreviation only use latent space representations of the world and of ourselves. So it could be more. I don't know if it fits to your lecture, if I'm gone wrong on a different street.
No, I mean, but there's two questions, no?
Mm-hmm.
Two quite big ones, no?
Definitely.
Yeah, okay.
And we have time.
Nee, thanks. I mean, I don't know if you feel the same, but for me the latent space comes back to this idea of the interpretation, the space where it's actually informed by the kind of the apparatus, no? Whether it's a human or a machine, through its history, its social context, its cables, its making, etc. So I think that for me, the latent space is also the space that I think that we explore as artists most often. That's maybe why we're certainly, perhaps many years ago in the beginning, we were a bit more interested in AI. For me, it certainly has dropped since then. But you know, this idea of having a different perspective, because you know, the kind of conditions of possibility of their latent space is different. For me, it's definitely different. But I'm not really interested in evaluating it in a qualitative way. More like it just affords different possibilities, I think. And now I don't remember the other question.
I can just maybe react to that because I was kind of struck by what you were presenting, and I think what you're saying and what really pertains to what I presented as well is like this media quality of flattening. You know, of drawing the world into the space where it's represented in a way that is machine readable. On the other hand, that's photogrammetry, and on the other hand, it's basically better interpreted by human beings. Sort of. At first, it was interpreted by human beings in your example, but it's also machine readable. You know, and it's the same with, of course, with language. You know, you have to draw a thing that is very very lively, very like with all the semantic relationships you have, with everything that goes with language, all the context. You have to find a way to draw it into a space where it's easily processable, you know, be it by humans, be it by machines. That doesn't make a difference in the first place. And you know, Sibylle Kremer calls this the Flächigkeit, the flattening of things that have us make calculations for centuries, basically, and always also have helped us develop machines that calculate this kind of things. If you go back to the original meaning of algorithm, it just means something that you can do without thinking, and you can do it on paper. We have been doing it on paper for centuries, and it's also something that a machine can do in the end. But you need to have the space, this representation, this spatial representation, this visual data in a way. That's what I was getting at with the vector space, because a vector space, of course, is a list of numbers, which is in itself already a spatial representation of data. You know, a list is something that has an order, and that's why it's readable by us and by machines with a certain informational effect. And in this kind of space, it gets interesting for artists, I think, because that's not only where machines work, this is also where we can manipulate them to work differently. That's what Parrish does. Of course, she starts to calculate the mean values that are generated in the vector space and just changes them and makes the machine do something differently, because it's just bound to its algorithmic logic. And we know that. As artists, we know that, and we make it usable for us, sort of in that kind of in that kind of setup, right? So I think that's where we go together in this. You know, it's all about machinic representation in the end. So I think, right?
Yeah, and that's really interesting because if I overlook the current research on like the outlook of what is coming in the next years, then we can see like startups and companies like spatial intelligence by Fei Li, for example. They are trying to build the models for robotics and more spatial AI machinery, and so it's quite interesting to see that the ultimate goal for these endeavors is to build a spatial intelligence. They're really calling it spatial intelligence as well, and at the same time using representations, mathematical representations, who are using spatial representation, like a spatiality as well. So it's like a doubling, or I don't know what we're coming then, what we're coming to then, but it's, right now I think this is the next step to build up on the multimodality and going for a deeper or more complex world models and world insights about the world. And how do you do it? You have to formalize informal things, practices, knowledge, tacit knowledge we are using unconsciously and stuff like this. And for doing these world models, they need to formalize all these things. It's really interesting. Yeah. Yeah, sure. Yeah.
No, because I was thinking like what you're talking about in a way is obviously they're trying to overcome the shortcoming of a machine not having a body, right?
Yeah.
Obviously, they need this kind of embodied knowledge as well to be able to, etc. But I was thinking about, sorry, I'm going back to your first question, but because you said like, well, what's the difference, no? Like if it's a human or a machine in a way. And I was thinking about, but the thing is like, actually, these machines are not, as it stands, independent at all. Like they're also depending upon like armies of not just moderators, but trainers, like humans who are usually working in squalid conditions and like thousands, like tens of, like really large amounts of humans to also power this training, not just the training, but also even when they're being used. So is it really existing that it would, does it exist that they operate on their own actually? Like it's a question, because for me, this does not, so far it does not exist. And so I'm wondering if it even makes sense to think about that. Maybe it's more interesting to think about the kind of conditions that produce, like if they start, okay, we're doing this embodied sensory experiments, and then what kind of army of humans will be mobilized for that training, no? Like, what then happens? I mean, that's my...
I think they are already preparing for that by using many POV videos from people doing dishes and trash cans and doing talks on the sofa and stuff like this, and then they are using these materials, this training data for like this self and world modeling. But let me come to another thing, which I think is a topic for both of you. You had it in your title, the hallucination topic. And I think maybe I'm wrong, but I understood your talk that maybe you're using these hallucinations of the models for producing literature in a kind of a way. And I want to tackle this elephant in the room. What are these hallucinations anyway? Are they really hallucinations, or are they more like a memory function of remembering of the model of what it has trained before, what it has learned before, and because it's just not a database query. It's more, for me, it's more like a remembering. I don't know. What do you think about this?
I mean,
Sure.
Stop me if you want to say something, but I think for me, when I was thinking about this, I didn't even have time to talk about it, but I guess for me the term hallucination is quite strange. Maybe strange is not the correct word. It's, for me, hallucination, I think about something that's almost mystical or something out of the ordinary. You can have a hallucination if you're extremely tired, if you're doing drugs, if you're, I don't know, if you're having a psychosis. These are like exceptional moments, right? And for me, like we didn't get to talk about it yet, but I've been looking into this, the Wikipedia AI cleanup to take care of all these hallucinations, no? And because when I think of hallucination, I think of something exceptional. And I look at these pages, and it's extremely boring. It's really banal. There's nothing exceptional about it. And actually, if you do the exercise of the cleanup, it's really just a tedious fact-checking exercise. And so for me, the hallucination goes back to, again, rendering this kind of exceptionalism or trying to make it something that it's not. No? For me, it's quite banal, actually. So I guess for me, the hallucination is maybe a misleading term.
Yeah, but I think so too. But I think this is what it's about in so many artistic endeavors working with AI, right? Because you were starting with this, of course, with this concept of hallucination, and that leads some people to say, aha, hallucination is something so human, right? And it's not human at all. It's just really something that happens in the data space that the AI in this frozen representation of the world that it just got from its statistical training data, of course, and we call it a hallucination in ChatGPT because it just does not relate to what we know about the real world or what's in the internet about the real world, of course, right? And it's just something it comes up with when it's prompted with a task it just can't fulfill, and then it tries to generate a statistically probable answer coming from its training data. So an hallucination is just something that reveals something about the algorithm, basically, right? Or about the training data. Namely that it's not there. That there's something missing there. And so in that way, it's maybe there's an analogy there between humans and machines, because an hallucination also sort of tells us something about our brain, how it works when we're in a dream state, or how it works when we took drugs or whatever. And that's sort of the analogy I would draw, but not in the way that this makes machines more human or anything, because it's a totally different concept of revealing what's underneath our sanity, or whatever you want to call it, or sane discourse that's under the carpet, if you will. Right? But there was a question by Paul, I think.
Oh, I didn't want to interrupt the panel. I can keep it for later.
You're not interrupting.
Should I get a microphone? Or?
Yeah, sure.
I really I have a problem with this term hallucination, or with the way that I'm not sure if it's the AI industry or if it's our own desire to sort of put all these processes into a realm that's, as you said, is somehow magical or mystical, because it started with Google Deep Dream, so it's dreaming, it's hallucinating, but no, it's lying. Or it's creating, because as I mentioned in the beginning of my talk, this little anecdote about ChatGPT inventing a chapter. There is a chapter that exists, but it didn't know it, so it invented something that is probably quite similar to the chapter in question. So it seems that we have trained these systems towards a desire to please. So it's not hallucinating, it's not dreaming, it's actually aiming to please somehow. Just a remark.
Yeah, but there's something there, I think, if I could just... I was also thinking about what you guys were talking about in the morning, about real-life data creating a new sort of reality, right? Because that is already happening, of course, when there's this case of a large language model that's prompted to find a reference for a paper. I think it was a law paper or something like that, and he couldn't find one, so went about and wrote its own paper and had it in a place where you can just automatically put a paper in. They don't have a really good review process, and it was just published. And so, and then it referenced that paper it wrote itself. So that's a quality of reality making, or that's not even hallucination anymore. It's just something. It's a simulation or whatever. I'm not a Baudrillard fan, but it's something like a creation of things. And I think this is something we're going to have to look at in the near future, because the next step in AI will be systems with much more agency. You know, something that books your flights, something that books your travels, you know, buys your groceries, and you know, just going about in the internet and having agency on your behalf in that space, which opens up, of course, a lot of ideas about artistic usage, I think. But it's also quite. It's also quite a new way of creating reality through data, I think. So that's the point of talking.
Yeah. Okay, that's really good, because in our pre-discussion via Zoom, I mentioned that, and today you talked about Turing as yourself, about the Turing test, and in his famous paper from 1950, he mentions 9 possible objections about the intelligence of machinery, and if I remember correctly, the 9th was Lovelace's objection, where it's about the question whether or not machines or artificial intelligence, whatever it is able to produce something new, or does it only things we program it to do? And so I think for an artistic or creative process, or for questions of authorship and stuff like this, it could be quite interesting to think about it, not just on a philosophical or an ontological level, but just in a creative processes. What is actually going on then when we are tasking the LLMs and stuff like this? Is it just a remix of society, or is it something individual, subjective, new, and stuff like this, like a human artist would do? And I find this is a really interesting question. I would like to hear what you're thinking about it. Yeah.
I can start. So.
I don't think I will say anything about that, apart from to say that for me the argument of newness in art is so frustrating that you know, this compulsion of newness is just a market-driven sort of vector, no? And so in a way, for me, I don't really see I don't really want to think about, is the machine making something new or remixing? I don't even believe in this concept of new somehow.
I think actually with Turing, the exact wording is machine can surprise us. It's not about originality and creativity, which is important, I think. It's about the element of surprise. And I'm not sure, I think I can make something of that, because yeah, of course. I mean, we all know about, you know, the inability of large language models basically to write a real new text because of the technical setup, in a way, you know, because it's a statistical generation of the training data and so on and so on. We know about that, but I think, well, on the one hand, these kind of examples that I showed, if you go beyond the hood and if you sort of disturb their statistical regeneration of training data, you can of course have an element of surprise of something new, or at least of some sort of machine intelligence aesthetics. You know, that is possible. But on the other hand, I would like to say, I think, I mean, it's a problem in literature already, because you know, there's you can buy yourself an AI book generator for $20 a month, and it just spits out 20 novels, 20 popular Sachbücher, and then you can sell them on Amazon for $1 a piece, sort of. You know, you can make a business with it. And these kind of books usually are not surprising. They're not good, of course. You probably don't want to read them, but to some people, surprise and newness is just not something that is desirable. You know, if you want to read a romance novel, you don't want to be surprised, like, whoa, what's this? You want to have it adhere to a certain plot, you know, a certain figure constellation, and that's fine. You know, it's totally all right. I mean, there's so many human authors that do not surprise at all, and AI is just so much it's not much better. I think it's just much quicker in creating this kind of content. So, and I think we have to just acknowledge that human culture is not only, I think that's why you're getting at too, human culture is not only about originality. Sometimes it is, but it's also about reproduction. It always has been. And the whole question of remix culture, we've been talking about this since 2000 at least, since Lev Manovich's thing. So that's basically nothing new in a way. Of course, there's a difference, I think, in this remix of culture with artificial intelligence, because now it's a statistical generation. It takes up much more training data. Manovich was talking about somebody who just has a very distinct knowledge, a very distinct taste, a very distinct collection on his flash drive, so he can create something new out of that sort of. And there's originality there in the creation of data that he perceives to be important enough to take into account sort of. So that's maybe the difference of talking about remix culture in the 2000s and now. But in the end, of course, it's nothing new that media regenerate our collective memory. So.
Great, thank you. And I think that points to something you were mentioning in your talk as well, like this transforming the machine readability of the world into a formalized process, and this leads to I think you said like a monoculture of like these square tomatoes, or these tomatoes who are machine readable, and there's always this danger of getting monoculture by formalizing for machines. And I was wondering if the same could happen if you're seeing these LLMs today, or these trained models which are mainly trained on European, US American data sets and stuff like this, like we're losing like a cultural diversity or stuff like this, or diversity in general. I don't know. What do you think about the...
Yes.
Yeah. Or how to counter that?
I can only say maybe that, like, of late, my frustration has been, not of late, but let's say last year, I was looking at essays, and it was extremely frustrating because all the ones that were written in ChatGPT, like, it's super clear and it's always sort of lame, and so that for me was totally frustrating. I think it is definitely something, I mean, we've seen it for even if you look at the internet, it's built on American spelling English, all the coding is in English. Like that language has already sort of flattened many other languages almost out. Now we're speaking English. None of us are English native speakers, actually. So I feel like I could make a million examples to affirm your point, and I'm trying to think of one that will not and I'm not able to think of it. Maybe you can.
I was just thinking about one point you need to make about this is probably don't just look at generative AI when you talk about AI. It's one aspect of it which has gained much attention in the last years, but AI is so much more, and it's much bigger than that, and it's much better at other things than language generation or visual generation, at least. Like data mining and these kind of things are much more interesting. And one thing that's just around the corner is basically there's an app called Demand Sense, which is already used by 95% of German publishers, that calculates remissions. Sort of you just have to punch in an ISBN number, and it calculates how much you're going to sell with that book based on the data going back to 1950, I think, or something like that. So this is very good for publishers because they can calculate how much paper they have to buy, and the printing costs. They can calculate their printing costs. Also, they are not in a shortage if the book accidentally hits, the German Buchpreis or something like that. And so this kind of thing is actually quite good. But now there's a new feature which calculates the whole thing based on the expose and author hands in at the publishing house, which is sort of something that makes you think about how many books that are actually risky, that have not been done yet, will be produced when publishers are actually using this kind of thing. I'm not saying everybody will use it, but there's so much economic pressure right now at German publishing houses that there will always be, an incentive to do so, of course. So I think, of course, there's this kind of flattening of culture. At least there's a new incentive to not try something new, but actually to do something that gives you, some sort of medium range cells with what you're doing in the book publishing world. So this kind of thing is of course happening, and AI is, in this respect, generative AI is not even a problem for German publishing houses. I think they will keep it out as long as possible. I think, or lector make editing so that it's better and have so much human tinkling with it that the text is just much better than anything that GPT will ever produce. But this kind of thing, of course, will have an effect that is, in a way, horrifying. But on the other hand, I don't know, maybe there will be publishing houses that will say, okay, we don't do that, we're going in the risky business. There's usually always an opening for people who want to do something different. So that's probably the cultural, that's the cultural dynamics I'm imagining for the next 10 years, I think.
Sorry, can I ask though, is it really a function of the technology? No, when we think about what data has been used for the training, I think that in my view, it would be problematic to attribute that to an agency of the algorithm, actually. I think that this is the data that it's being trained with. It's also like, we've been talking about certain systems of power that benefit from, so for me, this is also a question that comes back to how the technology is servicing certain interests at the expense of others, for example, no?
Yeah, and of course the promise of a success generator, an AI success generator, who's in general incompetent for this. I think we have some more minutes, and I'm sure you have questions as well. Yeah.